now we're doing some interesting stuff, some real math here, some real trigonometry. Okay, so we're going to find the sine, cosine, tangent of pi over 4, pi over 6, pi over 3. Very special angles, and we'll talk about these all the time. Okay, so just remember now, I'll be going back and forth between radians. I just switched to radians on you. But just remember, pi over 6, if I made you convert it, is $30. Okay, so that's 30. That's 60. That guy, of course, is 90, pi over 2. And then this one would be 45. You can convert all those to check them if you want. All right, so I'm going to draw a triangle with a 45-degree measure, a right triangle with a 45-degree measure in it. Okay, so this is 45 degrees, or pi over 4. So now I need sides. Okay, so I'm going to do a little trick here. I'm just going to let that side be 1. I could let it be 5 or 10 or 20, but I'll just keep it simple, let it be 1. If that's 1 from geometry, you remember that there's 180 degrees in a triangle, so that also has to be pi over 4, and that side would have to be 1. A little Pythagorean theorem makes the hypotenuse the square root of 2. Okay, and that's how I find all the trig function values of 45 degrees. Sine, pi over 4. Cosine, pi over 4. Now you don't have to repeat this. It's kind of like how I figure it out. You just have to remember them. And these are something that you're going to have to memorize. Okay, so just start doing it. Now they're going to pop up all the time in this class. But it wouldn't hurt to memorize them or just write them all down on a piece of paper and keep it handy. And then eventually you will remember them. You can use parentheses here if you want. You don't have to. This is read the sine of pi over 4. Remember, this is the input to my sine function. The angle is the input. So that means the sine of pi over 4 is 1 over root 2. And we have to rationalize these. We haven't done this yet. Cosine is the same, 1 over root 2. The tangent is 1 over 1, meaning the cotangent's the same. Now, I'm going to rationalize these in a second, but first I'll do the reciprocal, because it's a little bit easier. Root 2 over 1, root 2 over 1. Now remember, rationalizing, you multiply top and bottom by a form of 1 that gets rid of your radical in the denominator. So that becomes root 2 over 2, a very famous number. And then the cosine, of course, would be the same for this angle. Okay, very famous number because it's the sine of a special angle. All right, start memorizing. Can we fill those in? Let's fill those in. Sine of pi over 4, root 2 over 2. Typo. Cosine, tangent. Cosine of the angle, tangent of the angle. Cosine pi over 4, the same. Tangent pi over 4, 1. Start memorizing. Okay, or if you don't memorize the angles, just memorize this triangle, right? Because if you have that committed to memory, or if you can like reproduce it real quickly, then you can get all of the trig function values of each of those angles, which are the same angle, 45 degrees or pi over 4. All right, let's do that again for our 60, 30, 90 triangle, right? This is 30 degrees, this is 60 degrees. This one I got to get a little more creative with, so I'm going to draw a 30, 60, 90 triangle. A little bit to scale. Now, if I try to do the same trick I did before, I would call my short side 1. Here's the problem. I need another side, and this was the problem I ran into with this application problem that I couldn't finish. Okay, so if I need another side, here's the trick I'll do it. I don't expect you to know how to do this, but see if you can follow it. It's pretty cool. I'm going to mirror this triangle, make that 60. That would be 30. So now I have two 30, 60, 90 triangles. And what just happened? Well, if this is 1, then this would have to be 1. And then if this is 60 from geometry class, this is a 60, 60, 60, or an equilateral triangle, meaning this has to be the total distance on this outer triangle is 2, making this 2, the hypotenuse 2. All right, and now that I've used that little trick, I can kind of drop this second triangle. Hope that made sense. And I can use the Pythagorean theorem to find this side, root 3. I got that memorized because I've done it a million times. It would be a squared plus b squared equals c squared. B squared would be 4 minus 1. B would be root 3. Okay? So the sine of, let's do 60 first. The sine of 60, opposite over hypotenuse, root 3 over 2. Cosine of 60, 1/2. Tangent of 60, opposite over adjacent, root 3. Let's look at the 30-degree angle. Sine, opposite over hypotenuse, 1/2. Cosine, adjacent over hypotenuse, root 3 over 2. Tangent, opposite over adjacent. So I'll write this down because I got to rationalize it. And then I'll rationalize it. And then I'll commit it to memory. Okay, I cannot emphasize enough how important this chart is. Memorize these values. They're going to come up all the time. Very, 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 very important. For example, let me just show you. I don't want to get too carried away here, but I'm going to ask you. Right now we're just working with angles between 0 and 90, right? But let's say we're going to get over to like quadrant 2. We're going to look at bigger angles. Let's say I want to take a look at this angle, and that's 150 degrees. And I want to know the sine of 150 degrees. Well, it's going to depend on what this little angle, we're going to call this a reference angle when we get to this lesson. And that reference angle is 30. And these have something in common. In fact, they're the same thing. Sine of 30, I'll kind of explain why later in a later video. But what I want you to know now is that if I want to get the sine of 150, or this would be, if I went down, this would be 210, because this would be 30. Or if I got all the way around 330, I went all the way around, that's 330 degrees. They all have almost the same sine value. We're going to talk about negatives later, but they're all going to depend on the sine of 30. That means you need to know the sine of 30 in order to get all these other angles. Okay, so that's just one example of why this is important. But we're going to see these all the time. So make sure you have this chart, maybe reproduce this chart, have it handy until you have them memorized, because you're going to see this all the time. Oh, now I can do this problem. So I would set up an equation. I'm trying to find how high is allowed to reach up. So I'm trying to find this height. Let's call it b. And I'm going to set up an equation. I'll use the sine function. See if you like this. The sine is opposite over hypotenuse. And that will allow me to solve for b because, and only because, I know what the sine of 60 is. Right? Because we just talked about that. And I remember now that that's root 3 over 2. And this will allow me to solve for b. Multiply both sides by 16. It wants an exact answer here. So 2 over 16 is 8. So b would be 8 root 3. And it's feet, which is kind of weird. Right? Usually when we go decimal for that, but it's just wants an exact answer. So again, we always go back and forth between exact answers and decimals. I could plug that in my calculator and get the decimal equivalent or decimal approximation.